Right, so, good. Okay, so this, yeah, sorry, probably this is the most dry and kind of difficult to put across standing talking in a lecture of all of the lectures in this course. There's a bit more code and syntax in the slides than I'd really like, but they're all together in one place so that you can look at them in the lab. So I'm not going to try and work through the code in front of you here because it's all a bit tedious. But you've seen it, and hopefully what I describe around it you'll recognize when either you're in the lab or when you're doing the assignment, and this will give you some clues as to how to go about doing it. So the scenario, the type of thing that I'm going to be talking about today is, so far we've been running MapReduce jobs on files that are in Hadoop, but they've been rather fixed in terms of we write a set of code and then we run that code, and then if we want it to do anything different at all, read a different, well, not read a different file, that's the one example that we can change, but anything about the code, we go in, change the code, recompile it, it's all a bit, of a faff, and then you run it again. And there are certain things where it would be much easier if you could just send in some parameters and then you didn't have to recompile it all the time, and there are a certain set of things you can control by just sending in some parameters. Actually also you've been doing a bit of this sending in parameters already, but perhaps you haven't quite noticed. And then so the question is, well, okay, if I want to send in a parameter, maybe some of you have got to the point where you're doing the word count and you're trying to exclude stop words, right? So at. You could just program those straight into the mapper, right? You could read the row and then you could exclude a list of words that you typed in, compile that, run it, it's all fine. And then when you look at the results, you go, oh, yeah, there's a word I should have excluded, I missed that. Well, okay, so we put it into the code, we recompile, we run it again. It's all a bit tedious. It would be easier if we could either send in the list of stop words as just a long and variable length list of extra parameters, still a little bit tedious, but you could do it, or, rather more usefully, include a small file that is somehow sent to every mapper when the job is run, which includes the list of, in this case, stop words, right? So then setup, which I told you about before the break, our setup method could open that file, read the stop words into some local array or whatever, and then use that dynamically. And when you run it, if you go, oh, look at that, there's a stop word I've missed, you don't need to recompile or anything, you just add it to the little file that you send in and run it again. I think I am, sorry, I'm getting a coded message from the staff, from the front row, asking me if I forgot to, yes, thank you. That shows my level of confidence, so I was unable to say that, yes, I clicked a button 3 minutes ago. Where are we? Here. Yes, I am recording. Oh, that's interesting. Okay, right. Yeah, so that's what I'm going to tell you about today. And when you're running a normal program, that's not really a big deal, right? All the files are there. Your program could just open that exclusion file like it opened any other file, read from it. You send parameters in when you run a file and they're just there available in the arguments. But when you're running a MapReduce job, it's a little bit more complicated because you run the one program on main, but then that same, or at least the map and the reduce methods of that program, are run in lots of different places. So the question is, and this is what we're going to talk about today, how do I get either those parameters that I want to send in or a file, how do I actually share that across all of the nodes so that it's available to my map and my reduce methods, but without physically putting it onto all the nodes? Because remember when we looked at HDFS, there was no sense in which you could choose a node to put the data on, right? And there was certainly no sense in which you could say, make sure this file is replicated to every single node, right? You can't load it up ahead of time and expect it to be there for your mapper to have a look at. So this is what we're going to be talking about today. There's a built-in mechanism which effectively does that, but only for the life of the program. So what it actually does is takes either some parameters that you want to send in or a small file, shares it across the network temporarily so that every single node has access to it. Then when your MapReduce job runs, it can look at that file, read its contents, make use of it and so on. So that's what we're talking about. So that's the general kind of problem that we're going to solve. Oh. Hold on. It's moving on your screen, but not on mine. Why is it doing that? Somehow, in checking whether I was recording or not, I've broken it. It won't move on for me. Okay, I'm just have to look around a lot. No, I'm not going to do that. Maybe if I start it again, sorry. No, the mouse doesn't work. Right. Sometimes if this screen doesn't work, the recording doesn't work either. And so I feared if I kept going on that screen, you'd get my voice talking through the slides, but only ever the front screen, which is what it was showing on here. So I think we're all right now. We're lined up again. Right, so far, this is what you've done. Okay, you're used to, you've got your jar file, you've compiled it, you've made your jar file, and then you type Hadoop, jar, tell it you want to take this jar file and run it. Then you give it the name of your jar file, the name of the class within it, some optional options which we haven't really looked at yet, and then an argument list. All right. So that's what you've been typing so far, and generally, so far what we've been doing at least is the arguments at the end. That's what args is short for. It's not the noise you make when your file doesn't run. Is the input path and the output path. Okay, so that's what we've been giving it so far. Where in HDFS have I stored the data I want you to process? That's the first one, and then the second one, where in HDFS would I like the results to be written? And so far that's all we've been doing. But that argument list, although we've had 2 entries in it, it can be longer. All right, we can add other arguments to that which are picked up by the Java program and used for whatever purposes we want. So, for example, and this is the example I was talking about at the start, let's say we want to run our word count. So we've called it words.jar, and I've got a main class called word count, and it runs that, and I've got 2 locations on HDFS. This slide was made when the old installation of HDFS had /home instead of /user, so just be aware of that if you're copying things. But it's basically, those are the things that you've already been typing, so you probably know about that. And then the second version, kind of halfway down the screen, you can see it's exactly the same, but this time I've got 3 extra arguments that I'm sending in, a, I, and at. And those, my little example here, this would be a slightly odd way of going about it, but it works as an example, are the 3 stop words I would like it to pick up and send to each of the mappers. So basically what I want the mapper to do is read a row, whatever it is, an entry from the file that's being processed, and not bother to count anything that's just an A, an I, or the word at. Okay, and you can see that you could make that list longer, but pretty soon that wouldn't be a very nice way of doing it, right? Because you'd have to remember what they were every time you ran it for a start. But at least we could send in some parameters and not have to recompile our program every time we did it. So maybe for a little practice at first, that would be the way to do it. And then I think all of you have done enough Java to know how to pick up the arguments from a Java program that's been run. Okay? When you type your main, you maybe just type this automatically or cut and paste it from the very first time you ever did it, but you'll notice that it receives a set of parameters called args, and that's an array. It's an array of strings, and it's that set of anything that you type space separated after the name of the program that you want to run. Okay, so args 0, the very first argument in that array, that's that first HDFS path that I gave, which is specifying where I want to read the data from. Okay, and then args 1, that's the second parameter I gave. That's the HDFS path where I want to write the data. Okay, so those two, we've already met those. We've already been doing that. So we have actually already been providing two arguments to our Java program already, those two paths. So they don't kind of magically get sent in. The code that you had in your main method does actually pick those up and make use of them. And you can see the two lines of code there, file input format, add input path, and set output path. Those two methods are in the code that you've been running in the labs. Some of you might have read it through carefully enough to spot it, maybe not. But now you can see where it's picking up. When you type /user, /username, etc., that goes into args0 and then args1 for the results. And then those are sent in to the MapReduce method when it runs. All right. So that's why you type those in that order. If you wanted to type them in a different order, for example, if you wanted to do the results file first, you could do that and just swap the 0 and the 1 there, right? That's all under your control. That order isn't kind of magically setting something when it runs it. You're actually picking those two things up. So are we all happy now why we're typing those in that order, where they come from and how they're picked up? We could, if we wanted to take a step backwards, not bother with that, and we could hard code /user /your username /beer.text or whatever we were processing directly in where that args0 is. But then you'd have to recompile your program every time you wanted to process a different file, and that would be a little bit tedious as well. So hopefully now you can all see the role of those first two parameters and why they're there. And then after that, although we haven't been using it yet, we could pick up some more parameters, args2, args3, 4, and so on. And those we can do what we want with. So hopefully you can immediately see how we'd get hold of those in the main bit of the program that we're writing, because it's just in that array already, right? We just refer to it as args2, for example, and whatever was typed in that second location, in my example here it would be the letter A, that would be instantiated into the position 2, so the third one along in that array, and then the next position, position 3, would have an I in it, and position 4 would have at in it, and we could pull those out, right? And we could, for example, ask the Java program how long is the args array, and we could keep pulling those out until we ran out of its length. So everybody see how you might do that. There, so args2, args3, args4, and so on. Now, we've got those locally in main, but we can't really do anything with them in main, or nothing really interesting. We could print them out just to show that we'd got them, I suppose. And you might be tempted to do that as a first little test. But actually what we want to do is somehow share them across the cluster so that every node has access to that argument. Now we can't just do it directly. We can't in our mapper say args0, args3. It doesn't know about them because it's on a different machine from the one that you used to run the thing in the first place. And it doesn't have direct access to this arguments array. Okay, so we need some other method of picking that up and sharing it across the cluster. And actually it might be that the things that you want to share across the cluster were not picked up from the arguments array, they might have come from somewhere else. So we need a more generic way of sharing parameters across the cluster. And so that's what the code here does. So now we're starting to get into slightly more lines of code, but this is inside the main, so you've all got a version of this and you've all had a little look at it already, although most of the time you spent looking at the map and the reduce methods so far. But all we're doing in here is we've already got our configuration that's set up, I think, in most of the code that you've got. If it isn't, you just add that line. But then the next line, the important bit, conf.set, so conf is the name you've given to the configuration that you're going to be sending around. Then in quotes, the name of the parameter that you want to send in. So it might be exclude word or whatever you want to call it. So not my param in general, something a bit more meaningful. So that's kind of like a variable name. All right, so we're naming the thing. And then args2 in this case says take that second, well the third, the argument after the two files, and share that with all of the nodes in a parameter that I've called, in this case, myParam, or it might be exclude or whatever you've called it. All right. So that causes Hadoop to share that particular variable across all of the nodes that are involved in the MapReduce and give it the name that you gave it, so myParam in this case. All right. So you do that in main, and that's it. That's it kind of set up to be shared. You don't have to worry about which nodes use it and which nodes don't. You don't have to worry about are one of the replicas of one of the blocks of my data on this node or not. Hadoop sorts all that out for you. You're just saying to it, here we go, this is the one I want to share. All right. And then the bottom line here, this is inside either your map method or your reduce method or perhaps the setup or cleanup or any of the other methods that we're running. So this context.get configuration, that gets hold of the configuration you set up in the main. So we're talking about the same thing. And then, well, you can guess conf.get, the name of the parameter you want to get. That returns, in this case, a string, well, a text, because we're in Hadoop, right? So text being Hadoop's version of string. And it puts it, actually I've called it a string there, sorry. It puts it into that variable. So that's now available locally in my mapper or my reducer or whatever. So really, in one line, well, 2 lines of code in the main, 2 lines of code on the node, in the map or the reduce, I've shared that parameter and got hold of it, and now I can make use of it. So if that's a word I want to exclude, for example, I've got it right there to say, has the word I've just tokenized, does it match this word? And if it does, don't count it. Okay, so I think it's probably reasonably clear, is it? Questions about that? So that's sending those in. Now, we used set there, that top one, and that sets a string value specifically. And this is a bit like I mentioned this with the writable types. Really, I think they should have called it set string, because that would have made it a little bit more explicit. But actually, that's what it means. Set on its own is set string. If you want to set a different type, then you use the associated set method. So set int sets an int, set float sets a float, and so on. Okay. So you do set float in the main, and of course get float in the mapper or the reducer or wherever it is you're running it. So when we pass things around, we're passing them of the right type, and we're using a method that's associated with that type to do it. And if you've got lots and lots of strings, and it's a bit tedious to set each one at a time, then you've got this set strings method, note the S. You give it a single name, and then you give it as many values as you want, and that will set it up at the other end as an array. So then, actually that's finally how we'd probably do our variable length set of words to exclude. We could do set strings and send an array to the mapper for excluding them. All right, so that's that. And you could also, if you're a little bit naughty, if you've got a mixed set, rather than doing a set and then a set int and then a set float and so on, you could just serialize them all like I've done at the bottom here. I've comma separated them as a set of strings but with commas in them, and just tokenize that at the other end. Which, well, it's not brilliant Java style, but it gets the data across quite quickly. The only other thing to look out for is the parameters, when you type them on the command line, they come in as strings, all right? Regardless of what you type. If you type A, it comes in as a string. If you type 5, it comes in as a string. So if you want to treat that 5 as something else, an integer or a float, then you have to convert it. So that's what I'm doing at the bottom there with parseInt. That says, here's a string, turn it into an integer. And there's parseFloat and parseDouble and so on for the other types that you might need. So that's really just a reminder that you're going to need to convert anything that you don't want to be treated as a string into something else. Right, okay, is that set of things clear? Raising any questions so far? Okay, good. Hopefully it's reasonably straightforward. And then at the other end, no difference here really from what you've already seen, except I'm using, on the second line down now, I'm using getInt. I've given it a name there that kind of suggests what it might be. You'd use your own name. And the only other thing probably to point out is, do you see the 0? So to get int my param comma 0, you need to give a default value in case that parameter has not been set. Because these aren't variables at this point, so it doesn't have a way of checking. But when it turns it into a variable, it needs a value to put in there. So you need to give a default. You might then, if it's really important to know that it was missing, put a line that checks, but you need to provide it with a default. And that's it. So that's passing variables around. And you can use the get half of things in the mapper, the reducer, the setup, cleanup, all of those node side methods. So before I move off from that, does that raise any questions about either why you would want to do that? It's probably not the point really to ask about code. You can play around with that in the lab and I'll help you with that. But you got the concept at least. You're happy with that? Okay. I should think so. It's not. It's too bad. Right, now we're doing for time. Good. All right, so that's parameters. That's if I want to just send in, you know, a small number of things. Or it might be, when you did the word length count, you might want to send in a single parameter that says, ignore words less than this. That might be a nice thing to try in the lab. For a single parameter, you send in a number, and it ignores words with fewer than, I don't know, 3 characters in them or something, right? Have a go at that. But if you've got something larger to send in, and this is where the the word exclusion list is a better example. Let's say actually we've got 20 or 30 words, stop words, that we don't want to count. Well, you don't want to be typing those on the command line every time, right? You want a single file that contains them, and you want to somehow make that file available to every node. So this is where this distributed cache comes in. This is the idea that it is a temporary store for usually a small file that's going to be shared across all of the nodes and used for the running of your job. So I say probably small because remember the whole MapReduce philosophy is you're moving code to data rather than data to code. So you're not trying to send in massive quantities. This isn't sending in the data to be processed. This is just maybe a parameter file where you've got like 20 or 30 parameter settings that you like to keep in a file, or an exclusion list like we're doing here. It's that kind of size, right? Because it's going to be spread around, so you need to think it can't be massive. It's not the data you're actually intending on processing. So it can be a file that's already somewhere in HDFS. You could put it somewhere ready to be used for this, or actually you can just send it in from your local store. So for you guys at the moment that would be your H drive when you run the job. So in that second case you say run this MapReduce job, and while you're at it get this local file and share it across the cluster, and then when it's done it's all lost from the cluster again. So it's like a kind of parameter wrapped up, a parameter set wrapped in a file. So those are the options for that. So we'll look at the two of those. Again, a little bit of code. Really just have this as reference when we're in the lab. Again, sorry, the /home should be /user now. So similar pattern to what we did before. You set things up in the main method before you actually set the job running, and then you access it from the mapper or the reducer or the setup or wherever it is you need it. So again, in the main in the main method, it's pretty straightforward. You use this add cache file method, and you just, because remember these are already in HDFS, but they're only on one node, right? So they need to be grabbed and shared across all the nodes. So here we're just saying, I want to add a file to the cache list. That's its path in HDFS, and at the very end, after the hash, is a label, a final fragment that gives it a name that allows us locally in all of these little map or reduce methods to refer to it, because they can't access the full path. All right, they're not going to be opening an HDFS path. They're going to be accessing something in this local cache, that they've been given. Okay, so they can't access it via the whole path, so it needs a name of some sort, particularly if we're sending in more than one, like I'm doing here. So I've called it rather unimaginatively first and second. Okay, so you give it a name, and that tells, what that does is then grab that file from HDFS, bundle it up, share it across all of the nodes, and give it a label so that those nodes can access it by that label. In this case, first or second. So then all we need to do inside something on the node, so in the reducer or the mapper, I've done it, and this is the most likely place that you would do it, I've done it in setup. Because if you think about it, if you're sending in a file, you don't want to open that file, read from it, and close it again for every single line of the big data set that you're processing. So doing it in the mapper is a bit wasteful, right? Do it in the setup, you open it, you read the exclusion list once, store it in an array, or whatever you want to store it in, close the file, and then you're done. You don't need to look at the file again. So this is a perfect example of using the setup method that I talked about last time. So you can see that I've done that there, and you can see some code that basically just, this is Java being a bit verbose, but really I'm just, I'm getting the configuration, I'm getting the list of cache files, that's an array, because there's an opportunity to add more than one. So I'm getting, in this case, I'm just getting the first one explicitly. I'm splitting it on a hash to get the fragment bit at the end, and then I'm using that to set up a reader, because that's now just a local file. All right. So probably the thing to do is make use of that code in the lab, and then if it doesn't work or you can't quite follow it, just ask one of us in the lab. So that's the basic idea. It starts off with an HDFS path, and that gets shared across to all of the nodes, and the nodes access it by splitting off that thing at the end. There's also a get fragment method, that's what that little comment there means, that does the same thing as splitting it off a hash. So you can use either of those two things. And that's basically it. Once we've got hold of it, we open the file, read its contents, exactly as if it were a true local file. And then Hadoop deletes it afterwards, so we don't have to worry about that. Yeah?
How can this cache line go from without the map?
The
Cache line is your array.
cache line.
The last line.
String cache line goes. Yes, I'll come to that next. Yeah. In about 2 slides' time, I think. Yeah. If 2 slides later from now I haven't, then just. Yeah. Yes, that is a member of the overridden mapper. So we'll see that in a minute. But before we do, I'll just mention. So that was the files that were in HDFS, and again we use /user, /username, etc. to say where it is. And you might want to set up, if you're doing it like this, you might want to create a directory in your HDFS space where these go. Call it, for example, I've called it cache. Right? So you don't want to mix the cache files up with the data, because then you'll do your word count on the data itself. In fact, I had a few students last year, got it the wrong way around, it's quite understandable, and they did the word count on the cache, but they sent the cache in as the thing. So they did a perfect exclusion of every word that was in there, because they were excluding everything in the thing. So their results came back empty, and it took us a bit of head scratching to work out why it had run perfectly but produced an empty result, until I spotted which directory they'd sent in. So try not to make that mistake. And of course, if you want it to be somewhere there, then you use copy from local, as we've already been doing, to get it into the HDFS. So I've already said everything that's on this slide. It's copied automatically. You don't have to do it. You don't write the code to share it about or anything. The only thing you really need to think of is if you have got a cache directory, a cache folder on HDFS, I don't know, maybe sometimes you want to look in there and see if you still need everything that's in it. But they're only small files. As long as you haven't got too many, HDFS doesn't care. It's only if you've got thousands of small files that HDFS starts to care. So you're probably not going to come to that. So, good. Now we return to your question. I've read it into something in setup, but how does that something become available to the map method or maybe even the reduce method? So we'll stick to the map method for now. And so you can see I've done it here. I've extended a mapper up there, and that stuff is all stuff that you've seen before. The new line that I've handily highlighted in blue, just to answer your question, is I have this now private member, which is a string, which I've called EXCL for exclusion. And at first, when I just create the method, I've just set it to, by default, be empty. But then in setup, you can see what I've done now on the second but last line, just before I close the file, is I've assigned it a value. I've read the line from the exclusion file, assuming my exclusion file only has one line, and I've assigned it to that member variable. And because that member variable is a member of my mapper class as a whole, it's available to all of the methods that are inside my mapper class. Okay, so one of those methods is setup, so that's where I actually put some values in it, and another one of those methods is map, and so now I can just access it as a member variable. So because setup and map are both methods of the same class, my overridden mapper class, they both share access to that member variable. So I guess that's the question that you were asking. Yes, good. Yeah, so we can do what we want, I suppose. Compare the tokens that we're getting from the file that we've just read and not count them if we find a match in our exclusion list. Okay, so is that, we're all right with distributed cache, or at least the idea of what we're trying to do. You can have a go at running it. Okay, and then just finally, how are we doing? All right. For the last little bit of this, now this last bit is kind of extra. You won't need this last bit for the assignment. It doesn't really turn up in the labs either, but it's some extra stuff which kind of fits into the topic of what I'm talking about today. So I'll quickly tell you about its existence, because it might end up at some point being useful to know. So there's a couple of other things that you can do. One version of what I've just been telling you about, which on the surface looks a lot easier, is you can use this -files flag. So if you run it with -files, then you can list files that you want sent to the distributed cache, and it'll pick those up automatically and share them around for you. But if you want to use that, and you can also send in some other options as well. There are lots of settings for the way MapReduce works, things like the minimum number of spills from the map memory that needs to happen before the combine is triggered, for example, and there are a whole load of these different things you can set, which are a bit tedious to go over in a lecture. And if you run Hadoop in a particular way, which I'm about to describe for you, you can send these in as options. So you do -d, and then the name of the option equals, and then some value for it, like the minimum number of spill files, or the minimum number of reduce jobs, right? We've talked about that for a bit. So you can set that kind of thing directly from the command line, but in order to do that, you have to change the way you've written your main file and change the way it runs the Hadoop process. And you have to start using this thing that's called the tool runner. And some of you, if you're observant, will have noticed when you run the program I gave you, well, it's very verbose, but one of the complaints it makes is that you're not using the tool runner. And it says if you use the tool runner, there are a whole bunch of other stuff that you can do that aren't available to you in the more simple way that I've given you at first. So this kind of answers that question if we get to that point. So it requires a bit of moving around of the code, but basically we're going to have a new class, a tool runner class, and it does absolutely everything that your current main does. And in the end, all the main will do is call the tool runner. But doing it through this you're extending some stuff that the tool runner already does inside Hadoop. And because it's doing all of that stuff, it's picking up the files that you send in, it's picking up the parameters for the configurations that you're sending in. So it's doing all of that stuff for you. So it just it does make it a little bit easier. So all you need to do is extend this configured class and then implement a tool in it, and that's what that kind of first line of code's doing there. So we've already, Dave's already told you in his Java lectures about extending and implementing, and here's an example of doing both of them at the same time. We import some classes. There's no point in me reading those out, but there's a list so that when you try this, you'll remember to make sure you've imported them. And then we just, inside our tool runner extended class that we've just declared, we need to implement a run method. That's our one responsibility that's given to us. And it's inside this run method that we put everything that we've currently got in our main method. So basically, you declare it with the code that I've got here. You cut everything from what you've currently got in main, paste it into here, and that's pretty much 90% of the work done. So it's not terribly onerous, but you need to get the right imports and just get it in the right shape. But we can play around with that in the labs. It's impossible for me to really explain it properly in a lecture. But you can see what's going on here. Okay, we've set up configuration, we've set up the job just like before, and then we've got all that other stuff. So that will pick up the cache files for us and make them available. And then we can use the code I showed you before, or this get fragment that I mentioned, so that's how you do that bit. And then finally, all we have in the main, so we took all of that code out of main, it's now empty. The only thing we need to put back into main is this system.exit and then toolrunner.run. And that .run, that's the method that we've just extended and put our own stuff into. So it runs that. We send in the arguments that we get and the class that we want to run. And that's it. It does all of the rest of that for us. So I hope you followed everything up to and including distributed cache. I expect the tool runner stuff, there's no context really for it. So I expect you've got a vague idea that it exists now, but you're going to have to play around with it in the lab. It's just a different way of doing it, so it doesn't even achieve anything kind of really nice to explain. But there are some notes there for you anyway about it. And then there's a whole bunch of these configuration values that most of them just tune the way Hadoop runs. And on our small cluster and with your small files, that makes a limited amount of difference. But once it's bigger and you've kind of got more in depth of the fine-tuning of a Hadoop job, then these things start to be a little bit more important. So we're kind of now towards the extremes of what I really need to tell you about in this class, but for completeness, it's good to know about the existence of the tool runner at least. So I've managed to fit an entire lecture into the allocated time for it. Oh, I should say, hopefully you got the email, but there isn't a 5 o'clock lecture today, and there won't be in the next couple of weeks. But we've got plenty. These aren't cancellations, these are just, we've got plenty of time to fit in what's left. Right, so that's it. Hopefully you've got a vague idea now that it's at least possible to take parameters and files and spread them around the network for your MapReduce jobs. And we'll have a go at doing that properly in the labs. Okay, thanks very much. Sorry? Which lecture's next? Oh, you mean topic-wise? Ah, yeah. I think we've finished MapReduce now. So, hold on. Sorry. Hive. Yes. Yes, Hive. Stop that.